We will start with the basics about artificial intelligence. What is artificial intelligence? So this is a buzzword in the market today. Everyone speaks about AI, isn't it? Let's look at the way the legends have put across artificial intelligence. Stephen Hawking says that AI is likely to be either the best or the worst thing to happen to humanity. That is, he believes that either it's going to transform the world like anything or destroy the world. And Dave Waters says that in the last few years, artificial intelligence, virtual assistants will be as common as the smartphone in a few years. If you have noticed, 10 years back or 15 years back, if you had heard of this statement, maybe we would have laughed at the Dave Waters. The reason is we did not envision a state where machines would start dominating our life. 15 years back, we were not so addicted to machines. 15 years back, we did not have access to so many machines. Today, you have artificial intelligence agents surrounding you. The mobile that you carry, the apps that you have installed, at least I can confidently say that at least you have 50% of the apps which are driven by artificial intelligence or machine learning. So be prepared for this new revolution that is going to impact you. The next one is Bill Gates. You all know Bill Gates. He says that humans should be worried about the threat posed by the artificial intelligence. Considering the power of this technology, Bill Gates believes that AI is going to be a bigger threat for the human race, which Elon Musk also says the same thing. So everyone is having a very strong opinion that AI is powerful, but also dangerous. Only when you understand what AI is, you'll be able to understand the statement also. And Andrew Ng says AI is the new electricity, which is a very powerful statement for me because there are only very few revolutions or very few innovations which have transformed this human race. Like the wheel, the fire, the internet, and now artificial intelligence. Only some technologies have transformed the way the humans think. And today, if you notice, AI has made a big difference from that point of view. So it's the same case now. How are we going to implement this AI and how AI is transforming things today? You notice a lot of changes coming to that. Okay. One second. Can I request all of you to be on mute? Somebody has unmuted themselves. Ibn. Okay, done. Okay, good. So Andrew Ng says that it is a new electricity. It's going to create new business models. It's going to change the way the people think. Just imagine 30 years back, internet was not greatly accepted or was not greatly there in the market. But today, if you notice, internet has changed the way things are happening. If there was no internet, maybe I would have been sitting in your campus doing this training program. Thanks to the internet, today I'm able to take this training program sitting in Bangalore. That is the difference that this industry, this technology has created, internet. So the same way, artificial intelligence is also going to impact everyone's life in the coming days. With that, let me quickly move on to the agenda for the first session. We're going to discuss about 3 topics. What is artificial intelligence? What makes AI special? And finally, how AI is creating this paradigm shift. That is what is the plan for today. What is artificial intelligence? Let's begin with the basic question. What differentiates a machine from a human being? Can anyone make a guess? I think we have already discussed this, so you should have intelligent answers now. Can I get some answers in the chat? What differentiates a machine from a human? So post your answers in the chat window, please. Feelings, good. That is emotions. Anything else? Humans have decision-making ability. Okay. Machines don't have. Humans can think. What human cannot do, machine can do. Okay. Are you sure, Raja? There are a lot of exceptions, right? Isn't it? Think about it. Common sense, yes. Performs programmed activities, yes. Lifespan. Which one has more lifespan, machines or humans? It depends, right? Depends on whether it's a Chinese product or American product, kind of. A machine does what human gives us input. Okay. So the key aspect is intelligence. Intelligence is the one which differentiates humans from the machines. Okay. And what is intelligence according to you? How do you define intelligence? If I ask you whether you're intelligent, I'm sure you're going to give me the answer that yes, I'm intelligent. But how do you define intelligence? Knowledge? Good, Aishwarya, good answer. Anything else? How do you define intelligence? Ability? Okay. Thinking out of the box? Thinking out of the box is intelligence. Okay, fine, we'll keep it. Thinking spontaneously? Okay. Skills? Ability? Doing the right thing at the right time? That is intelligence or morality or ethics? What do you call it as? Maybe, Gigi, you need to think there. Ability to apply the knowledge acquired. Good, ma'am. Yes, that is application of knowledge. One is acquiring knowledge, the other one is application of knowledge. Nice. Good reasoning. Okay. So reasoning, I can take it as a creativity is another one. Yes. So if you notice, this is what the dictionary tells you when you check what is intelligence. It is the ability to acquire and apply knowledge and skills. These are the two things which you have to do. Okay. And considering the context, you need to remember that intelligence is all about reasoning and insight. These are two words I want you to remember. Insight. Insight is nothing but intelligence that you gather from data. Reasoning. Reasoning is why certain things are happening. What is the reason behind that? Can you define, can you understand what those reasons are? So reasoning and insight are two powerful terms which you need to remember in this intelligence aspect. Now, when we define intelligence, I want you to look at intelligence from 5 different dimensions point of view. This is how we define intelligence. One, reasoning, which is the most popular way of looking at intelligence. That is why certain things are happening. The second one is learning. That is, from whatever that has happened, can I learn something so that I can apply that learning again? So learning is acquiring knowledge, correct? So reasoning is interpreting something from the knowledge. Learning is acquiring knowledge. Perception. Perception means how are we able to perceive with the help of the senses? How are we able to think? Okay. How are we able to interpret? That is called as the perception. So the ability of the human being to capture information with the help of sensors. That is, we have 5 senses or 6 senses. By the way, how many senses humans have? 5 or 6? How many senses humans have? Okay, everyone says 6. Nobody says 5. I'm surprised. So what are the 6 senses? Can you just quickly put it across in the chat? What are the 6 senses? Hearing, speaking, taste, smell. Good. Only one left. Which one? Touch. Vision, yes. Vision is also there. Then which one is the additional one here? Hearing and speaking. Yeah, 5 senses. And what is the 6th one? The one that you mentioned, which differentiates animals and humans. The 6th one is called as a common sense. If I have to put it in simple terms, it is the ability to expand, ability to grow. Okay. Now, if you notice, can I take any one of these senses, especially the cognitive senses, which we call it as 5 senses? Can I take any one of them and give it to a machine? If I do that, that means that is one of the components of intelligence. Okay. The next one is problem solving. Can I solve complex problems? If I'm able to solve complex problems, it is called intelligence. That's why we always try to assume that anyone who is good in mathematics, we say that, okay, the person is good in intelligence. That's a very lame way of defining it, but yes, that's how it is used. Linguistic intelligence is the most underrated one. That is ability of the human being to learn new languages, to understand the structure of new languages, and speaking those languages. That is called as a linguistic intelligence. So to summarize, there are 5 different ways of looking at intelligence, and these are the ways. And anyone who has any one quality or all the qualities, they are considered to be intelligent. Then how do you define artificial intelligence? Artificial and intelligence, these are 2 words. I'm just trying to bring them together. So artificial means not naturally available. Intelligence means one of these 5 dimensions. So if I take any one of these dimensions of intelligence, that is reasoning, learning, perception, problem solving, linguistic ability, if I take any one of these and give it to a machine and make it intelligent, then it is called as artificial intelligence. The machine does not possess this intelligence naturally. So I am providing this intelligence to the machine, and thereby the machine is intelligent. That's why it's called as the artificial intelligence. If I have to go by the bookish definition, AI is an area of computer science that emphasizes the creation of intelligent machines that work and react like humans. So some of the activities the computers with AI are designed for include speech recognition, learning, planning, problem solving, etc. And AI is a very old subject. It's not like something new. It is 65 years old. First time, John McCarthy, who is considered to be the father of artificial intelligence, in 1955, he mentioned that we have to do more research on artificial intelligence, understand how we can create intelligent machines. That's the first time he coined the word artificial intelligence. So you may be surprised because, I mean, we talk about AI so much. We may be of the assumption that AI is 10 years old or 20 years old, but actually it is 65 years old. They have been doing a research on this topic for a long time. But the point is, they were not very much successful in the past few years because they were ahead of the times and the technology was not advanced. But in the last 10 years, the technology has advanced to a greater extent, and thereby they are able to make use of the technology to rapidly see some growth in this R&D space, AI space. And AI has been commercialized to a greater extent in the last 10 years. Thereby, every person is exposed to this concept of AI now. So how do you define AI? How John McCarthy was defining AI? He was saying that it is a science and engineering of making intelligent machines, especially intelligent computer programs. So when I say AI, maybe most probably what will come to your mind, it'll be the natural humanoid robot that will come up. But that need not be the case. AI can be a simple computer program also. Like for example, the Google that you use is actually AI driven. You don't have a physical form to it. It's just a computer program which is running behind the screens to fetch you the best results when you search for something. So Google is an example of AI. And to look at other examples, to look at other definitions, the field of AI research defines itself as a study of intelligent agents. So any device that perceives its environments and takes actions and that maximizes its chances of success at some goal. So colloquially, if you look at it, artificial intelligence is applied when a machine mimics cognitive functions. That is, as I told you, the 5 senses. And also the function, cognitive senses and functions. Functions include learning and problem solving. So that is what is called as the machine learning, which we'll learn it in the upcoming slides. So what contributes to AI? Almost all the areas like psychology, neuron science, biology, maths, sociology, philosophy, computer science, everything. Why? Because what you are trying to do is you are trying to create the replica of the human intelligence in a machine. If you want to create the replica of human intelligence, first of all, you need to decode how the human behaves, how the human intelligence behaves, and then encode it into a machine. Now to decode how the human thinks, you need all these studies, correct? Within the human, what kind of things that are happening because of the brain. So for that, you have studies like neuron science, biology, and other stuff. Outside, what kind of interactions that happens with other humans. To understand that, you need to have studies like philosophy, psychology, and everything. To implement this, you need to understand mathematics and computer science. So that you will understand slowly as we progress through the program, you will understand the importance of mathematics, importance of computer science. Because Python, that's where Python comes in. You need a programming language to implement whatever AI is all about. Okay. So you need all these things to come together. Then what is AI system? So going by the popular definition, you can call any machine as a AI machine if it can learn from experience, or if it can learn to reason, or it can recognize images, which is one of the complex problems to solve, or it can solve complex problems, understand language and its nuances, and creating perspectives. So if you notice, this is nothing but definitions of dimensions of intelligence. So if I take any one dimension of intelligence and give it to a machine, I call it as an AI system. Okay. Can you guess who she is? Any answers from the audience? Sophia, yes. What is special about Sophia? What makes Sophia special? First machine to get citizenship. Okay, good. Anything else? Why did she get citizenship? Because it can express facial expression. Absolutely right, Arishti. Humanoid robo, we have been having it for a long time, Nandu. Okay, but the point is today we are able to see a robo which can express. So I would suggest to go and watch YouTube videos on Sophia. You'll be surprised the kind of expressions that Sophia gives, apart from the fact that Sophia is beautiful. Okay. So expressions and interactions also, Padmavati, like there are a lot of interactions with by a normal bot, right? Like for example, OK Google, Siri, or even Alexa. It is able to interact with you, isn't it? So there are bots which have that, but that doesn't make a difference, isn't it? But expressions, a bot which can express herself better, that's what is making Sophia special. So what are the areas explored in artificial intelligence? These are the popular areas: machine learning, NLP. Under machine learning, you're having deep learning and predictive analytics. You have NLP, natural language processing, speech, that is speech to text and text to speech, expert systems, planning, scheduling, and optimization, robotics, and vision. This is called as a cognitive vision or computer vision. People call it in different ways. There are different problems to solve using vision also. As part of this program, if you look at this, we are going to cover machine learning as a core area, because we are living in an era where we say that machines are intelligent, and machine intelligence is driving the creation of NLP bots, speech to text, robotics, vision. Everywhere, if you notice, machine learning is the core engine which is driving all these aspects. So if you want to learn what AI is and how AI agents are created across these spaces, you need to understand machine learning. And under machine learning, we are covering predictive analytics. That is, can I make use of the data to understand what is happening behind the screens? That's what we are trying to cover. Okay. How are we doing it? With the help of Python as a programming language. I hope you understand where we stand with respect to this program. Okay. So AI is everywhere today. It's in our phones, cars, shopping experiences, romantic matchmaking, hospitals, banks, all over the media. Everywhere you see, you have artificial intelligence. Just that we may not be realizing it, that there is a machine which is driving it behind the screens. There is an intelligent machine which is running behind the screens. So that's something you should remember. And why suddenly we are talking about this whole AI concept? As I told you, in the last 10 years, we have more data available thanks to the big data. We have more computational power available in the with the machines thanks to the Moore's law. We have more open source algorithms thanks to the open source community. We have complex models available for us to use. We have a lot of open source libraries which are available, which you will slowly understand when we get to the library concept in Python. Those are things which are making a difference today. And we have new set of tools that are available to analyze the large quantum of data that is available. That is called as the big data technology is available. So with more and more IT platforms coming into picture, there is a lot of value that is happening in the market. And that's where we say that data is the new oil and machine learning is the refinery. With all the data coming in, with machine learning algorithms applied on it, it definitely makes a difference in the market. So how do you realize the path to the business value? With the data that is available, you're able to apply algorithms and you're able to predict insights, the business insights, and those insights are helping you to take business decisions, which actually derives a lot of value for an organization. Okay, good. I'll take a pause here. Do you have any questions so far? You can put it across in the chat window. I would love to answer any questions that may be crossing your mind. Okay, no, sir. Thank you very much. If you don't have questions, you can put it across as no also. That's perfectly fine. Okay, good. Thank you very much. I've got most of the no's. So if you have a question, you can always put it across in the chat, please. I'll move on to the next topic. What makes AI special? So we'll start with an example. This is the same example that we discussed last time. But just to give you a recap. If I want to throw a paper ball into the dustbin, this is a very popular technique we always try, right? With this example, I'll try to teach you what is machine learning. I throw the ball into the dustbin. The ball doesn't fall into the dustbin. It falls beyond the dustbin, let's say. What is the learning from this particular experiment that is throwing the ball into the dustbin? I have put in more force. That's the reason the ball has gone beyond the dustbin. So now I have to reduce the force. Now I reduce the force and throw the ball again, second time. Now the ball falls before the dustbin. Now I am adjusting it. Okay, slightly more force. Third time I'm throwing the ball falls into the dustbin. So I can continue doing this experiment, and let's say, for example, 20-25 times I have tried this experiment. Now, having tried this experiment 20-25 times, I would have noticed a pattern. Like if I throw the ball in this angle with this force, I'm able to throw it into the dustbin. So out of 25 times, maybe 4 or 5 times, the ball would have fallen into the dustbin. And from that 4 or 5 occurrences, I would like to create an equation and understand how the ball has fallen into the dustbin. So what I'm trying to do is I'm trying to identify the pattern which works when a person throws the ball into the dustbin. What is the right pattern which a person should follow to throw the ball into the dustbin? This is what I'm trying to understand. So if you notice, if I ask you to write a program, a simple program to identify whether the ball will fall into the dustbin, you may be writing a simple program with a physics equation, right? You will say that, okay, this is the logic. I'm calling a function where I pass the input, and this is the logic I will use. I don't care about the input and the output. So I would say that any input that is coming in, it will go through the logic, and there is an output. The logic remains standard. Only the input and the output changes. Depending on the input, you get the output. So in machine learning, what I'm trying to do is I'm trying to understand how I can identify from the data the logic that is needed to recognize the patterns. Like for example, here, out of 25 records, that 4 or 5 records where the ball has fallen into the dustbin, can I see a pattern in it? Can I understand the relationship between input and the output? At what force did I throw? At what angle did I throw, which actually made the ball to fall into the dustbin? I'm trying to understand that. By fixing that, I'm able to understand the relationship between the two, and that relationship, I'm trying to express it in the form of simple equation. That is exactly what I'm trying to do here with machine learning. So in machine learning, what happens is you are having the past data with input and the output, and you're trying to understand the relationship between input and the output in the past data. You're trying to understand the relationship with the help of statistical algorithms. By analyzing the data, you find the relationship between input and output, and thereby you're able to run a program, create a program out of it. This program is nothing but the equation from the data. Okay, and for any new data that comes in, you're trying to put that data into the equation to see whether the ball will fall into the dustbin or not. That's what I'm trying to achieve it here. So to look at the differences, in the normal programming style, you do not care what the input is, what the output is. You worry more about the logic. But in the machine learning, your data, the input data is actually identifying the logic. Only from the data, you are fixing the logic. So as the data changes, the logic also changes. That is what is called as a machine learning. That is, you're actually making the machine learn from any data that it is getting exposed to. That is what is making a difference here. Okay. Any questions here? Jennifer, ma'am, you are the new person. If you have any questions, you can ask me, ma'am. You can put it across in the chat window so that we can quickly sort it out for you. So far, so clear for everyone? Okay, perfect. I'm moving on. Other students, I hope you have understood this. Why do you think, I mean, we are going to discuss about why AI is creating a paradigm shift. Why do we talk about AI so much? The beauty is the difference between the traditional programming and the conventional and the machine learning. Machine learning, you are creating a model from the data. With the help of the past data, you're creating a model which will help you to predict the future. So what is happening here? Prediction is happening here. So what is prediction? It is the process of filling in missing information. So what do? You are taking information which you already have from the past data. You call it as data, that is historical data or the past data, which is equivalent to the human's experience, right? Whatever we have as experience, it's actually stored as data in our mind. The same thing happens with machine. Just because it doesn't have a mind, we say that all the data, the historical data is the one which gives the experience to the machine. Okay. Okay, good. Sure, sir. Point noted, sir. Thank you very much, Ram, sir. Yes. So what we are trying to do is you are taking the information you have, often called as data, and use it to generate information you don't have. That is, for example, in the case of the dustbin example, 25 times I threw the ball into the dustbin. I have that information completely. I know when the ball has fallen into the dustbin, when it has not. Now, when I throw a new ball into the dustbin, before even throwing the ball, if I know what is the angle at which I'm going to throw, what is the force at which I'm going to throw, by putting it across in the equation, I can predict whether the ball will fall into the dustbin or not. That is the beauty of prediction here with the help of the data. So there are practical examples for this, like a credit card transaction. You can check whether it is legitimate or fraudulent. Like for example, I stay in Bangalore. I swipe my credit card here every now and then. And maximum I'll be swiping it for 5,000, 10,000. Suddenly my credit card is getting swiped in Thailand for 1 lakh rupees, let's say. Immediately there is an anomaly that is detected in the data. The machine quickly alerts the people saying that, look, some extra transaction has happened for Lakshmi Narayanan in Thailand. I doubt what exactly is happening there. Can you just quickly check with Lakshmi Narayanan whether this transaction is legitimate? So the alert is thrown to the customer care executive. The customer executive calls me to check whether I was the one who made the transaction. If I tell him that yes, I am in Thailand and I made the transaction, he will put it as legitimate. But if he realizes that I am in Bangalore and not made the transaction, then he will call it as fraudulent and he will block the card. Okay. So that is what is called as prediction. So Sankareshwari, you have a question. You are asking, like I said, process of filling in missing information is applicable for, I mean, it's not for the past information, Sankareshwari. If I have said that, I'm sorry. It is from the past information, you are identifying the process of filling in the missing information for the future. Prediction is always about the future. It is not about the past, but it is from the data that is available from the past. Okay. Like for example, 2-3 sessions, I continuously take the session and I'm seeing a pattern. Like at 6 o'clock, if the session has to start, how many people are joining the session on time? Fourth session, I'll be able to predict it accurately, like who are the people who can who will join the session on time, who are the people who will join late, who are the people who will ask questions during the session. I'll be able to predict all these things in the fourth session just by observing the first 3 sessions from the past data. Does that answer your question, Shankareshwari? Perfect. So we predict whether the car transaction is legitimate or not, or the person looking into the iPhone camera is the owner or not. So these are all simple predictions that happen based on the data that is captured in the past. So the new wave of artificial intelligence does not actually brings us intelligence. It is actually bringing in a critical component of intelligence, which is called as prediction. So let's take some examples and try to see how this prediction problem is changing the world. Transportation, let's take that up. Autonomous cars. Do you think the autonomous cars are new to this ecosystem? Not really. They were always there. There were vehicles, autonomous vehicles, which are running in warehouses. They used to work sincerely in the warehouses by taking some load from one shelf to the other. It was always there. Then why suddenly a lot of buzz about autonomous driverless cars? Because the cars that you're talking about, the vehicles, autonomous vehicles in the warehouse, they are designed with the help of if-else rule logic, saying that if somebody is walking in front of the vehicle, please stop. If the shelf is empty, move to the next one. So it doesn't have intelligence to decide on its own what to do next. But today, thanks to all the technologies that are available, machine learning, deep learning, and everything, today we can have a car put on the road whereby you can make the car intelligent enough to take a call what to do, to apply the brake or to press the accelerator. But there has to be a different logic, right? Because if you can't pick up this autonomous vehicle and put it on the road, because this vehicle will die immediately. Somebody will crash the car on this particular vehicle and it won't work properly. So because there are too many conditions also which you cannot code in. So if you have to create a driverless car, obviously the approach has to be different. So instead of thinking like an algorithmic problem, like if-else logic, can I look at it as a prediction problem? What would a human do in this case? Can I look at it as a prediction problem? That's what the companies are doing it today. If you notice, companies are trying to identify how human has been driving for a long time. What does the human do? If you notice, there is a pattern in the way we drive, isn't it? Like if there is a red signal, we stop. If there is a green signal, we accelerate. If somebody who is going in front is putting a right indicator, means we know that they are going to turn right and we slow ourselves down. If somebody is crossing the road, we have to apply brake. So all these are patterns. So that's exactly what these guys have tried doing it. They gave a car with its own eyes, ears, and everything with all the sensors. Now this car has been put on road and you're asking the human to drive the car on road. The machine will continuously monitor the data from all the sensors and it will start analyzing the data. It will try to see patterns from the data to check out what exactly is happening there and to identify what pattern is helping the people to take a decision, whether it is pressing the brake or accelerator or something. So based on the environmental data that is coming in, the machine starts taking the decision. So it understands the pattern, it is able to apply that pattern. That's how the autonomous vehicles are working on road. So if modern artificial intelligence is just prediction, why is there so much fuss about it? Because prediction is a foundational input. Anything and everything that we do, there is a bit of prediction that exists there. The prediction that helps us to take a decision. Our businesses and our personal lives are riddled with predictions, and often our predictions are written as inputs into decision making. So better prediction means better information, which means better decision making. So what has happened now, all the algorithmic problems are slowly becoming a prediction problems. Like if I ask you to look at the image and identify whether it is a cat or a dog, You may be able to do it because you are intelligent. But if I ask you to write a program to identify from the image whether it is a cat or a dog, maybe it may be slightly challenging for you because you cannot put all the features of the cat and the dog in the form of if-else logic and try to determine whether it is a cat or a dog. But instead, you can give the machine 10,000 images of cat labeled as cat and ask the machine to identify or understand what is the pattern in those 10,000 images, and then look at them as a, and using that logic, you can identify whether the new animal is a cat or a dog. So machine learning uses probabilistic models to solve these problems actually. So look at the practical examples. The way this problem has changed is the whole world has started looking at everything which could not be solved for a long time as a set of prediction problems. Like for an HR, with the help of the logic that we are studying now, you can identify who will do well in your organization. You can identify who can perform better in the next organization with the data, with the patterns that are existing. You can identify who will leave the organization next and what policies can make them stay. So almost like everything can be predicted with the help of the data that you capture by applying statistical algorithms on top of it. So I would always recommend one book when it comes to artificial intelligence. This is the book, Prediction Machines by Ajay Agrawal. I request you to buy this and read it. Read this book. If you're not a book reader, then check out his videos on YouTube. You will learn a lot about machine learning and artificial intelligence. Any questions? Are you with me so far? All good? Can I get a quick guess from everyone? Yes, perfect, awesome, good. Super, good. Let me move on to the next presentation then, okay? Just give me a second. Let me pick up the next presentation. Okay, I hope you're able to see my screen. So till now, what have you understood? You have understood what is artificial intelligence, what is machine learning, and how machine learning is different from other languages that you have studied so far, and how machine learning is able to solve a lot of new problems in the market. So before we move on, you need to understand what is the role of statistics and computer science in machine learning. If you notice, this whole machine learning can be described in the form of a Venn diagram like this. So at the end of the day, you should remember that we are using technology to solve business problems. So there is a business problem that exists in the market. You are trying to solve that business problem with the help of technologies like artificial intelligence, machine learning, analytics, big data. It can be any one of the technologies. So for certain problems, first of all, what you need to know is any business problem should be seen as a data problem when you're talking about AI machine learning. Anything that you see in this world, try to understand what data you would need to solve that particular problem. Like for example, if I ask you a simple question before even we get to the technical side of things, let me see whether you're able to think straight here. I would like to admit 100 best students in KV Institute of Management. And I want to use a machine learning model to identify the best students for my college admissions. Can you tell me what kind of, I mean, this is the business problem or the problem statement that you've got. How can you look at it as a data problem? Problem means I'm talking about a question to solve, not a challenge. Okay. What kind of data would help you to answer this question, that answer the question that who are the best candidates from all the applications that you have received, who can be given an admission offer from KV Institute? Can you make a guess? Can you put it in the chat window? Any responses? Okay, academic performance. Okay, good. Academic performance of the UG. I hope that's what you're saying, Nandu. So UG graduate with distinctions. Okay. Past students of entrance exams like MAT and TANSET. Yes. Okay. So good. Keep on adding, because you need at least 30-40 data points for you to identify who could be a better student in your campus. So how do we look at it as a data problem? Because for now you have understood that machine learning is about pattern recognition, correct? Now what I will do is I'll check the college database very clearly. The current college KV Institute database, I will take it up and I will try to see the patterns that exist in this database. Like how many students, what do I mean by success? First of all, successful student. I'll define that. I'll take the complete database and identify who are all the successful students. And from that, I will start seeing a pattern. I'll try to make use of that data, use machine learning techniques to understand who are all the students. I mean, what is the common pattern that exists between these students? So when I observe the pattern, I may be seeing some data about where they are coming from, which college they studied, which stream in UG that they studied, and which, I mean, Tamil medium or English medium students, or whether they're engineers or commerce students. So all these aspects can be seen, and you will start seeing a pattern, like who are all the students who are performing well. And now you have got an equation out of this model. This is what I call it as the machine learning model. From the past data that is available, you're able to derive an input and the output relationship. Input is nothing but the variables that we discussed now. Output is whether they are successful or not. So from this, you have identified the pattern of the successful students. And now you want to take the complete admission application data and you want to run each and every student with this model that you have built in. Now, anyone who fits into this model, the model says that it is 90%, 95% accurate in this model. Those students are the ones who could be a natural fit for your college, and you can believe that they will be successful in your campus. So this is how you are converting a proper business problem statement into a machine learning data problem. Okay, I hope you're able to understand the context here. So every problem, if you pick it up, you can always convert that to a data problem, and then you start analyzing the data. This is what I have done. So I've understood the problem. I am trying to look at it as a data problem. I analyze the data. And then once I analyze it, I can bring in mathematics and statistics to decode the data, understand the patterns that exist in the data. And for doing this, actually, you'll be dealing with large data sets. You'll be dealing with statistical algorithms, which are computationally costly. That is, if you're using a normal laptop to execute this, it's going to be very, very tough or challenging for the machine to do this. So you would be looking for cloud as a solution. Plus, you need a programming language to access the data and as well as to apply the statistical algorithms on data. Just like you are using Excel as an analytical tool. If there are 200 records of data, means you will use Excel as an analysis tool to do it. But if you have more number of data coming in, you may need a programming language to write customized programs to manage the data. That's where computer science comes into picture. So computer science plus mathematics and statistics together, they are coming together on the data to solve the business problem that arises. Am I making sense? Am I clear? Because I am going in a flow, I do not know. You have to tell me. If there is any question, please stop me and ask questions. I am here to clarify it for you. Being the first session, I'm just going through the theory. But once we jump onto the practice, there is no turning back. We are going to look at code only. Okay. So from mathematics point of view, at least what we are covering as part of this program is, you need to know that statistics is needed, and you can pick up any algorithm generally. Okay, like algorithms can be like linear regression, logistic regression, support vector machine. There are different algorithms that are available, which you can apply on the data to solve the problems. Okay, that's the role of statistics. Computer science is a facilitator, as I told you. And there are different views at the end of the day about machine learning. If you ask a statistician, he will say that it's all about finding the series of linear relationships that minimizes the error between a set of input and the output variables. So whatever that you predict, is it matching to the correct results? If not, what is the gap? Why is that gap coming in? Can I minimize the error by changing the technique? These are some of the things which you work on to ensure that, I mean, this is what is called as a machine learning according to statistician. Computer scientist, that is a computer science professional, will always say that machine learning is my area, and you are using a programming language to optimize a set of weights on the edges of a directional graph. I mean, this is a complicated one. So they view it slightly differently. Mathematician will always say that I'm going to understand the relationship between algebraic patterns that exist to find the best possible solution. And data engineer, the person who collates all the data from different sources for you to manage and process the data, he will say that it is a process of training neural networks using certain open source algorithms to maximize the F score. Okay. And business will always say that ML takes a lot of data and it costs a lot of money and sometimes gets nothing done. That's the perception that will come from the machine learning professional. Good. Any questions here? Anything? I will quickly move on to the, okay. This is something I want you to remember. This I call it as the cheat sheet of machine learning. When do you go for machine learning? When you don't do machine learning. You start and you automate. Do you need automation? If it is yes, good. If no, then continue with the manual work. If you are going to continue with automation, can you write the rules for the automation? If yes, then go for a simple rule-based one. If not, go for formulating the problem very clearly. So once you have the problem statement clearly defined, check whether you have the data to process this information. If no, start collecting the data. If yes, then check whether you have a regular pattern in the data. If you find regular pattern, good. That means you can find meaningful features. If not, it is a failure. So if you don't have meaningful features, then please enhance data and look for different sources. But if you have meaningful features, start measuring the success and keep refining the problem if you don't have the measuring success parameters. And this is what is called as a machine learning. When to go for machine learning, this image will give you that clarity. Okay. Any questions, anything? Any questions? If not, okay. You need to remember the high-level business architecture for the implementation. This is what we are going to learn in Python also, how to implement it. So what you do is you collect the data sources first of all. You understand where the data is going to come from. The data that you're going to solve that is going to help you to solve the problem. Once you have the data sources, then integrate them. That is, how can you bring data from different sources and integrate them in one common platform and store it here? So you use extract, transform, load from different data sources and then put it across in warehouses. Once it is there, then you structure the data that is available in this layer. Because once the data is ready and structured and organized, then you give it to the data scientist who has the ability to play around and work on the data. Okay, so that's the next step. That is where the techniques are applied by the person. Statistical techniques are applied on the data to derive insights. Once you got the insights, you are going to represent the data, insights in the form of dashboards so that the leadership can look into that. This is the standard business architecture that is needed for artificial intelligence solution. So any questions? Yes, no, maybe? Any questions? No? Okay, I'll continue then. I hope I'm audible to all of you. I know it's a bit of a theory session to begin the machine learning part. Yeah, in another 15-20 minutes, immediately after the break, we'll be moving on to the Jupyter notebooks. So what are the different languages? You have understood what is machine learning and how to apply it. There are different languages that are available for implementing machine learning. You have Python, Java, R, JavaScript, and Scala. The most popular ones are R, Java, and Python. And if you have a choice, you should always pick up Python as a programming language to learn. You have taken the right choice today by picking up this program, because Python is different from other languages. Python is different because it has its own open source libraries and other things, which makes it easier for you to write and complete a solution for a problem with minimal code, because somebody would have already written it in the form of library. You just have to use it. So that's how easy this Python as a language is. Okay. So Python is the leader with 57% of the data scientists and machine learning developers using it, and 33% preferring it over other languages for developments. Why? Wide selection of other libraries and syntaxes are very simple. So that's the reason we are organizing this program for machine learning using Python. So you learn Python as a language, and then you start building the model. Okay.